Fundamental to assembly language programming is the ability to perform bit manipulation, and the most fundamental of bit manipulations are the shifting and rotating actions. The simplest kinds of shifts are the logical shifts. A logical shift is one that assumes there is no sign bit, that all bits are shifted regardless of the position in the register being shifted. The first example shows a hex value being stored in the AX register, which is a 16-bit register, and being shifted logically to the left 1 bit at a time. The ones and zeros of the register are displayed by the function showAX, which also shows the setting of the carry flag. I'll show you how that works here in a minute. This is how it looks when you run it. The bits are shifted to the left, zeros are introduced on the right, and the bits on the left are just lost to the register. But the bit shifted out is stored in the carry flag. This is a similar function for shifting logically to the right. It begins with a hex value being stored in the AX register, and that register being shifted 1 position to the right 2 different times. The initial value and the resulting values of the register is displayed along with the carry flag. Shifting to the right works the same as shifting to the left, but just the opposite direction. Zeros are introduced on the left, and the bits on the right are duplicated in the carry flag. These two are simple logical shifts, but there are other shifts instructions that do it differently. This is an example of shifting left arithmetically. Now, there's nothing different here. Shifting to the left arithmetically is exactly the same as shifting left logically. In fact, the assembler generates the same opcode. The result is that when it runs, you get the same results as you did before, shifting left logically. Zeros introduced on the right, and the bits on the left are copied into the carry flag. Shifting right arithmetic is a little different than shifting right logical. This is the same bit pattern that we used before, and it is shifted to the right 1 bit at a time, but the bits have a different meaning. Shifting to the right loses bits on the right the same as it did before. However, it is a signed shift, so the sign bit is retained. On the left, the leading bit is duplicated, so a negative number remains negative and a positive number remains positive, even though the value is cut in half. Another way to achieve shifting is to rotate. The rotate left instruction works the same as a logical left shift instruction, but with one difference. The bits that are shifted out of the register on the left are the ones introduced on the right, so it's a circular operation, with a bit that is rotated from the left to the right also being copied into the carry flag. You can also rotate to the right with it acting the same as the logical shift right, with the bit being shifted out on the right being the one that is shifted in on the left, and a copy of it left in the carry flag. There is yet another way to rotate. Rotate carry left. This one uses the carry flag to hold the bit that's shifted out, but also the bit shifted in is the one that was previously stored in the carry bit. In effect, the register you are shifting has one more bit. In this example, the 16-bit register and the carry flag are rotated as if they made up a 17-bit register. Every bit shifted in comes from the carry flag, and every bit shifted out goes to the carry flag. The same thing is true when rotating right through the carry flag. The bits of whatever register is being rotated go through the carry flag back around to the other end of the register. Those are all the shift operators. Any kind of shifting you need to do can be built based on those commands. To show you how the shifts work, a special function call was made that displayed the bits in the AX register along with the carry flag. Here's that function. In the data segment, a string of 16 characters is declared to hold the ASCII of the bit values, and the single byte is declared to hold the ASCII of the carry flag. Notice that even though they are not on the same line, they actually make up one long character string. This code sets the ASCII of the carry flag to either 1 or 0, depending on the value of that flag. The 16 bits of the AX register are set in a loop. Before the loop is started, a counter is set to 0. At the top of the loop, the AX register is rotated to the left into the carry flag, and a branch is made according to the setting of that flag. So either 0 or 1 is put into the location of the string, according to the offset determined by the counter. At the bottom of the loop, the count is incremented by 1, and if it is less than 16, the loop is made for the next bit. Finally, the string is output. Notice that it was necessary to get the carry flag setting first because this loop does destroy it.